Your brain turned itself off last night, locked the doors, started running its own private show. You had no control over what played. You couldn't pause it. You couldn't leave. And when it ended, most of it was already gone. Scientists have been studying this moment for over 100 years. And the honest answer to why it happens is still the same. Nobody actually knows. That's not modesty. That's not a gap waiting to be filled. That is the current state of neuroscience. We can map every region of the brain. We can track electrical signals firing across millions of neurons in real time. We can measure the exact chemical changes that happen the moment you fall asleep. And we still cannot tell you with certainty why. Every single night, your brain manufactures an entirely fictional world and makes you live inside it. You will spend roughly 6 years of your life in that fictional world. 6 years of experiences that never happened, people who don't exist, places you've never been. And every morning, you wake up with almost no memory of any of it. The question is, why? Why does the brain do this at all? What is the point of 6 years spent inside something your own mind invented and then immediately deleted? In 1953, a researcher named Eugene Oserinsky was watching his 8-year-old son sleep in a laboratory at the University of Chicago. He noticed something nobody had formally documented before. Behind the boy's closed eyelids, his eyes were moving rapidly, back and forth, in coordinated bursts. He called it rapid eye movement, REM sleep. And that accidental observation opened a door that science has been trying to understand ever since. What Oserinsky found was that sleep is not a single state, it's a cycle. Every night, your brain moves through 4 distinct stages, and it repeats that cycle 4 to 6 times. The deepest stages involve almost no brain activity, but REM sleep is different. During REM, your brain is almost as active as when you're fully awake. Your eyes move, your heart rate shifts, your breathing changes, and your body becomes temporarily paralyzed. Your muscles switch off completely, presumably so you don't physically act out whatever's happening inside your head. That paralysis is not accidental. It's a system, a deliberate mechanism your brain activates specifically during the moments it decides to generate a dream. Which raises the obvious question. If the brain goes to this much engineering trouble to create the dream state, it must be doing something important in there. So what is it doing? The first serious answer came from Sigmund Freud. In 1899, he published a book arguing that dreams are the brain's way of processing repressed desires and unresolved emotional conflicts. The unconscious mind, he said, uses the cover of sleep to express things the conscious mind refuses to face during the day. For decades, this was the dominant theory. It shaped psychology, psychiatry, and popular culture in ways that are still visible today. Then neuroscience caught up, and it dismantled almost everything Freud said. Not because his ideas were entirely wrong, but because they were untestable. You cannot design an experiment to prove that a dream about a staircase represents a repressed memory from childhood. The theory was too flexible to be scientific. It could explain everything and therefore proved nothing. So, science looked elsewhere. And what it found was a set of competing theories, each supported by real evidence, each contradicting the others in important ways. The first is the memory consolidation theory. The idea is that dreams are a side effect of the brain filing and organizing the day's experiences. During REM sleep, the hippocampus replays events from the day and transfers important information into long-term storage. Studies have shown that people who sleep after learning a new skill perform significantly better the next day than people who stay awake. And animals deprived of REM sleep show serious impairments in memory formation. The implication is that dreaming is what the memory consolidation process looks like from the inside. Your brain is doing maintenance work, and the dream is the noise that maintenance makes. The second is the threat simulation theory, put forward by Finnish neuroscientist Antti Revonsuo. This theory argues that dreams evolved as a kind of rehearsal system. Ancient humans faced constant physical danger. Dreams, according to this theory, gave the brain a safe environment to simulate threatening situations and practice responses without any real-world consequences. If you could rehearse being chased, being attacked, being lost, your brain would be better prepared to handle those situations when they actually happened. This would explain why nightmares are so common and why the most universal dream experiences across all cultures involve being chased, falling, or being in danger. The third is the emotional regulation theory. Put forward by neuroscientist Matthew Walker, this theory argues that REM sleep is essentially a nightly therapy session. During REM, the brain reactivates emotional memories, but strips away the stress hormone noradrenaline that made those memories painful when they first formed. The result is that you can revisit difficult experiences in a calmer neurochemical environment and gradually reduce their emotional charge. In this view, dreaming is how the brain heals. People with PTSD, notably, show disrupted REM sleep and an inability to complete this process. Their nightmares are not random. They are the same traumatic memories being replayed without resolution night after night, because the system that should be processing them is broken. The fourth theory is the most radical. Proposed by neuroscientists Francis Crick and Graham Mitchison in 1983, it argues that dreams serve the opposite function of memory consolidation. Instead of storing things, dreams are how the brain clears out useless or redundant connections. The random neural firing of REM sleep, in this view, is essentially a system reboot. Deleting junk, cleaning up noise, making room for the next day. Under this theory, dreams themselves are meaningless. They're the visual output of a deletion process, the equivalent of watching files move across a screen during a hard drive cleanup. The content doesn't matter. Only the process does. 4 theories, all supported by real evidence. None of them fully accepted. None of them fully disproven. And here's what makes this genuinely strange. These theories are not minor variations on the same idea. They fundamentally disagree about what dreams are for. Memory consolidation says dreams help you remember. The deletion theory says dreams help you forget. Threat simulation says dreams prepare you for danger. Emotional regulation says dreams help you recover from it. They cannot all be right. But science has not yet found a way to prove which one is. Part of the problem is that dreaming is almost impossible to study directly. You cannot observe a dream from the outside. You can only measure the brain activity associated with dreaming and ask people what they remember when they wake up. But dream recall is notoriously unreliable. Most dreams are forgotten within minutes of waking. The ones people remember may not be representative of what actually happens during a typical night of dreaming. And the act of remembering a dream changes it. The moment you try to hold on to it, you're already reconstructing it. There's also the question of whether all dreams serve the same purpose. REM sleep dreams are vivid, narrative, and emotionally loaded. But dreaming also occurs in other sleep stages, and those dreams are different. Shorter, more fragmented, less emotional. Are they the same phenomenon or something else entirely? Nobody knows. And then there are the experiences that sit at the edges of dreaming and make the whole question stranger. Lucid dreaming, where the dreamer becomes aware they are dreaming and can sometimes control what happens. Sleep paralysis, where the brain wakes up before the body does, leaving people conscious but unable to move, often with vivid hallucinations at the edges of the room. Hypnagogic hallucinations, the flashes of imagery and sound that appear in the moments between waking and sleep. These experiences suggest that the boundary between dreaming and waking is far less clear than it appears. That the brain doesn't simply switch between states, it slides between them and sometimes gets caught in the middle. Every night, without asking your permission, your brain does something extraordinary. It constructs an entire world, populates it with people, gives you a body inside it, makes you feel things that feel completely real, and then, in most cases, quietly erases the whole thing before you wake up. We don't know why. We have theories, we have evidence, we have a century of serious scientific effort pointing in multiple directions at once. But the honest answer, the one that neuroscientists will give you if you push them, is that we do not yet have a complete explanation for why the human brain does this every single night of your life. What we do know is this: the moment you fall asleep tonight, your brain will get to work. It will run its cycles. It will activate systems that have been in place since long before humans had language to describe them. And somewhere in the middle of all that, It will build you a world.